Hello and welcome to this screencast of Acme's shell, Win. Using a shell in Acme, Win. Win is a program that comes with the 9-term program. Its purpose is to enable limited shell access by creating a new Acme buffer. It also includes a send command that can be used to execute the current command in the clipboard. What's interesting is that what's interesting about the program Win is that it isn't a feature of Acme. It's a completely separate program that manipulates Acme using Acme's 9p server. Contemporary IDEs have to write plugins that have to be executed within the IDE. Furthermore, those same plugins are limited to one language at most, whilst the Win replacement can be written in Common Lisp, Java, Clojure, or Go, and it would work just as good if not better. Now, to be clear, it can be written in shell script, it can be in any language that speaks 9p. That being said, Win serves a good illustration of Acme's design, and it will be the main focus of this screencast. Now, the source code of Win is stored at plan 9, the variable plan 9, source cmd 9-term win.c, which stands at 896 lines. Now, let's just check where that directory is. Here's the directory, here's the source. Now, it may seem large, but again, if we do edit, basically grab all the content in the file and then pipe that to wc-l, which counts all the lines. And then, because of this sign, what it does, it will write the output to this directory plus the errors, as we can see. So it's 896. So yeah, it's 896. Now, to contrast, Emacs's eShell stands at, now I'm gonna do it live just because it's extremely interesting to see. It's in Lisp, and then we have a bunch of files here. I go to, I think it's eShell. Yep, it's a directory called eShell. And I do this, and you could see that now, if I may, I'll just do 16,081 lines. So, yeah, that's a lot of lines. Now, let's see VS Code's terminal. Now, Emacs is probably more optimized than VS Code, both being a non-Electron app, and more than that, being written in Lisp, which has a lot of things that can shorten the code, such as macros and other types of stuff. Now, what I'm going to do here is I'm going to do DUA awk print 2, which is going to get all the files, and then see if we can find any terminal file. Okay, I'm gonna go to this directory, and I'm gonna treat this directory as if this directory has the things that I'm looking for, which are what I would say the files for the terminal. So I'm gonna do the same thing here, files dash here. Now, I did a different command, admittedly, but because everything is spread out through different files, so I'm gonna grep anything that ends with TS, and let's just check the output of that. Now, TS, for those who don't know, is TypeScript. And then I'm going to do xargs wc-l. Now, xargs turns any lines into spaces. So, for example, if we had something like this, line 1, line 2, line 3, it would turn that into line 1, line 2, line 3 in one line. And after that, it puts those arguments after whatever I wrote. So wc.-l, it would put all the files here. So you put for example, this file and then this file and then this file and so on. So let's just do that. And that's 11,000 lines. Now, let's just do some very fast math. If I do, I think it's like this, if I'm not mistaken. Oh no, I have to echo it. That's fine. I want to see the percentage. And then I'm going to pipe that to BC. For those who don't know, BC is a calculator. Now, it doesn't work because I have to put some scale. And the scale is basically the floating point number. So it has 0.07% of the code of both implementations. Now, I did highlight the code before I showed the functionality. So I'm going to move on into the functionality. Or before that, I'm going to go into how win works. So let's open the file, and I'm going to read through the screencast script. Win's process. At first, Win creates a window through writing to acme-new CTL. So it writes it here to the CTL file descriptor. It calls a bunch of commands like name, dump dir, dump, and then scroll. So these commands. Now, interestingly, scroll does not exist as a CTL command in the manual. So if I do man for acme and then grep scroll, it doesn't have that command. So my guess is that it's a deprecated command. Though if I do grep dump, it does exist. Now, just to go back to it, I want to just make sure. Yeah, so dump here exists, dump there exists, but no scroll. That is only show. Afterwards, it reads a bunch of files like adder and data and so on, a body, and finally event. Now, if I look onto event, I think I'll find. I'll find something. Yeah. So the reason it does this is because if I'm not mistaken, when you open a file, when you open the new CTL file, it will return a number, if I'm not mistaken. So you have to write it and then read it. Though I could be wrong. So that's why it's reading a number, because each acme buffer has its own number. Event is the most important one, is the most important file, because by nature, acme buffers emit certain events. Now these events range from mouse events, so middle and right recording. So if I hold middle click and then I release, it's supposed to execute this. Or right recording, so if I select text by holding right click and then moving my mouse and then letting go, that's a right chord. Keyboard events for insertions and deletions. Writes to the body or tag file without the use of a keyboard, i.e. through the 9p protocol. So I covered before in, I think, the Acme running a fuzzy finder, where you can write to a body or the tag, right? So this event allows the user who's reading the event file to distinguish if it's the user typing at the tag or body, or if they are writing directly through the 9p protocol. And then access on other files like through the CTL file. So if any text is sent to the CTL file, it will show up in the event file that the user is reading, so this file specifically. So the way that Win works is that it basically processes keyboard events and writes them to a shell process. So it's important to note that the event file, when the event file is being read through, executions of commands like del through mouse coding will not do anything. So for example, if I do echo when ID, now for those who don't know, each buffer has a special echo $when ID. So here I have it 52. but if I do it here, it has a different value, which is 2. So that being said, if I do 9p read acme 52 event, it will just give me some things. But now if I do right click, it doesn't search. Normally it would search. If I do middle click del, it doesn't work. If I do get, for example, and then do some stuff here, sorry, get, not get f, it doesn't work neither. Only when I close this process by doing kill 9p and then doing that in different, obviously in a different acme buffer, then it could work. If I do get, sorry, yes, now it works. Now one note that I forgot to mention in the acme, in my acme tutorial, in the first one, is that you can copy text by using left click, by holding left click and then selecting the text, not letting go, but clicking middle click while you're also selecting. That cuts the text. And if you want to paste it, as I'm doing right now, so I'm still holding the left click, I didn't release it. Left click and then you do right click, and then good, you're good. So while you're holding left click, if you press middle click, it will cut. And while holding left click, if you do right click, it will paste. So middle click for cutting, right click for pasting. So let's go over doing some admin stuff with using Win. So Win is aware of password contexts and does some obfuscation. I'll just use the word hiding, does some hiding to passwords. Although the word is not grammatically correct, it's just I find this word hard to pronounce while I'm recording. So if I do win here, and then I want to change my user, I want to change it to example user, and then I'm going to type my super duper password. Please don't share this with anybody. PASSWORD. As I'm typing it, it hides every character, as you've seen before. So we can do very basic sysadmin stuff like cding into the home directory and of another user and creating a file and echoing into that file and then catting that new file and so on. So it has all the basic shell commands, and it doesn't implement anything new in terms of the shell commands. The shell commands are given through the shell program. So that's all fine and dandy. We can also do we can also use a REPL for development using the Win input. So REPLs can be used within Win and are easy and powerful to use. To help illustrate this, let's develop a simple sum all function in Common Lisp. Let's make it sum all numbers. Now, originally I intended to do Fibonacci, but Fibonacci proved to be more complicated than what this video intended. So what I'm going to do instead is do a sum all numbers function in Common Lisp. Now what does that mean? What I mean by that is if we give the function 5, it's going to do 5 plus 4 plus 3 plus 2 plus 1. And that's it. So it gives us 15. If I do 6, it's going to give us 6 plus 5 plus 4 plus 3 plus 2 plus 1. So let's just do some basic development. So I just did an enter because I don't like the indentation. Define a function. We use the defun function for that. Sum all numbers. We'll call all number x, and then if x equals 1, we just return x, and then else we do sum all numbers minus 1 x, and then we do x again, and then I guess it's 3 parentheses. Now to check the parentheses, I'm going to click between the x and the parentheses. I'm going to double click, and it will show me it will select the text that encapsulates everything, and then I'm going to do enter. Now you notice that this function is multi-line, but as I enter each line, it sends it to the SB cell Steelbank Common Lisp interpreter or REPL. Now if I do sum all numbers 5, it gives me 5. Sum all numbers 6, that's accidental. I can just, instead of writing it again, I can just modify the buffer, select it, and then do middle click to execute. Voila, it works as intended. Now, I did mention the send command, but I forgot to write something in the illustration. So one cool fact is that you can do something like this. Hello world. Copy it like this. So left clicking, holding left click, and then pressing middle click. Or I'm sorry, cutting it. And then you could do middle click here, execute the send command, and it sends it. Initially, when I wrote this thing about the send command, I thought it was specific to the win program. But if I do send here, if I select and then write the send, it sends it. But it only sends it to the end of the body. So the send command basically reads the clipboard and then sends it to the end of the body. So that's very useful and neat. And the next screencast, I'll include extremely useful functions that will help the user develop anything in the REPL. But that's in the next video or the next screencast. Now, let's see the next illustration. Using signals for escaping or cancelling processes. Since Acme does not have any Control, Alt, or Shift keybinds, it passes those keystrokes as they are to the Win program. Now, in languages like C, if one does something like this, this is an infinite loop, and the only way to break it is to do Control C to exit out of the process. In REPLs, like Common Lisp or Python or anything similar, you could do Control C, which signals an interrupt. What that means is that you should interrupt the current execution and respond to the Control C through the specified way. So what I'm gonna do is the Common Lisp version of that, and that's called loop. So I just called the loop function without any conditions. So what happens now is that I can type whatever and nothing will respond because it's still stuck on this infinite loop. How do I get out of this? I just do Control C, and it sends this weird character. However, we can see that Common Lisp has this sig int, and this is not exclusive to Common Lisp. If I do exit to exit out of the command, and then I do cat, and cat is now getting infinite input, I can do Control C to exit out of it. So Control C works as intended. Now, it's important to note that these features do not work in Acme 2K. And for those who don't know, Acme 2K is a fork of Acme that has some features like Control C and Control V to copy and paste respectively. So the reason that it doesn't work is because Control C and Control V are both bound to specific stuff, and that's why it doesn't work. Now this is admittedly a lost feature because there are many times personally where I have used Acme 2K and I wished to signal interrupt, but unfortunately it wasn't there. So you have to deal with that if you use Acme 2K, but if you use Acme, the normal Acme, you don't have this issue at all. Thank you for making it this far. And as a bonus, I just want to mention something, which is that the win shell command is extremely useful, and one thing that makes it very useful is that you can select text and modify it if you want to without messing up anything. So in Acme in Emacs this is found, but I think it does some extra functionality to make it work. But in Acme it's baked right into the text editor that every buffer, including the buffers up here and the buffers up here, and the buffer, every place where text is displayed can be edited. So the tag here, and the tag here as well. All of these are edited. All buffers are also editable, you know. You may not be able to put or in other words, to save those changes, but you're able to modify them. So that being said, I've heard about um, a lot of, I would say, programmers, yeah, like Russ Cox and Rob Pike, that use this to debug. So for example, if I had an issue with this function, the sum all numbers, I can add a note here, the original sum all numbers. And then to jump to this, I just say original sum. And so say I'm doing some other stuff and I forgot about it, I could do original sum, right click, and then it sends me back to this thing. So that's extremely useful. And also using the REPL is extremely useful, and as I said, that will be the focus of the next screencast. Thank you for watching. I hope you have a wonderful day, and see you in the next one.